Hi friends, this is Nagama Ramakrishnan and I am very glad to join you all again. Today we are going to see about numbers and the kinds of numbers. So first we can see what are numbers. So what are numbers actually? We are intimately connected with the numbers. We are count with numbers, we measure numbers and we do different calculations, and it is actually logically necessary in reality, and it is up to our mind that think of the numbers. So without mind there is no numbers, because if we find a perfect square or a perfect circle, there is no perfect square or a perfect circle, since that is the way of understanding concepts clearly. So only the mistake we do is we will not understand any concepts clearly. If we are clear with the concept, then math is not that difficult. It is very easy. Okay, so we can go with the kinds. So there are two kinds in numbers. One is real number and another is imaginary number. Before going to the real numbers, we can see what are imaginary numbers. So what are imaginary numbers? So when we compare to real numbers are still, and the imaginary numbers in certain sense doesn't exist, does not exist, because what are mm, if we find because if we find the square root of any negative number, we can't get any values. But in the another case, if we find the value of a square root of a negative number, we get the answer. So that is imaginary numbers. We get imaginary numbers. That is, if we find the square root of -1, we get it as I, that is small I, italic I. We represent this term to be I. And if we find the square root of -4, let me take it as an example of an imaginary number, we are getting it as 2I. That is, root of -4 can be split up into two terms, and that is root 4 into root of -1. So we know root 4 is 2 and root of -1 is I. So root -4 is 2I. So this is of imaginary numbers. So we mostly deal with the real numbers, so we can come back to the real numbers. So what do real numbers actually mean? So for that, we have to know what a number line first. So what is a number line? Here this is the number line, and here there is a line drawn, and in the middle 0. We have marked it as 0, and the right of 0 there are positive numbers 1, 2, 3, etc. up to infinity, and in the left of 0 comes the negative numbers -1, -2, -2 up to 0. This is said to be as a number line. And we can come to the definition of real numbers. So all the numbers that can be plotted in this number line is said to be the real numbers. So we can go for the examples so that it will be clear. For example, 1, yes, we can mark it here in this number line. So 1 is a real number. So we can go to some other number as some other examples. 0.5. Yes, it's lying in between 0 and 1. It is somewhere in the middle. So yes, it is also a real number because it can be plotted in this number line. And next comes root 2. Root 2 is 1.414, etc. So this value can also be plotted in this number line in between somewhere 1 and 2. So the root 2 is also a real number. And what about the special number pi? So if we find the value of pi, it would be 3.141 etc. So this can be also plotted in this number line. So pi is also a real number. So all the numbers, any numbers that can be plotted in this number line is a real number. So next we can go to the kinds of real numbers. So now we are going to see the kinds of numbers. So first we can see what are the numbers we know. Terminating decimals, non-terminating recurring decimals, non-terminating non-recurring decimals. So how they differ, we can see to the examples. So terminating decimals. What are the terminating decimals about? 0.54. For example, 0.54, 0.687, 0.942. Since it is terminating, that is, it stops at a point. 0.54, the decimal stops at a point. So it is called terminating decimals. So 0.687, it is stopping. The same as 0.942, it is also stops. And the next comes non-terminating recurring decimals. For example, 0.6666, it goes. It repeats the same, the 6, the number 6 repeats the same, and it has no end. So it is called recurring since the 6 repeats and it has no end, so it is non-terminating. And the next example, 0.222. So like this, if any kind is there, this is said to be the non-terminating recurring decimals. And the next comes non-terminating non-recurring decimals. For example, root 2. The value of root 2 is 1.414, etc. And pi will be 3.141, etc. So here there is no pattern. There is no repetition of numbers. It differs and it has no end. After the decimal point, there is no repetition of numbers, and also it does not end at a point. So it is called non-terminating because it does not end, the decimals does not end, and it is non-recurring since it doesn't have any specific patterns. If we come to pi, the same as 3.141, etc. Here also the number after the decimal does not have any pattern and it does not end. So it is non-terminating because it does not end, and it is non-recurring since there is no specific pattern after the decimal points. So these are the examples. These both, the terminating decimals and the non-terminating recurring decimals, both are said to be the rational numbers. These two are said to be the non-terminating decimals and non-terminating recurring decimals. These two are said to be rational numbers, and the non-terminating non-recurring decimals is said to be irrational numbers. And these both rational numbers and irrational numbers or both together form the real numbers. So the real numbers has two kinds, rational numbers and irrational numbers. So what is the rational numbers? Rational numbers, terminating decimals and non-terminating recurring decimals. Both together it is called rational numbers, and non-terminating non-recurring decimals is said to be the irrational numbers, and rational and irrational numbers together form the real numbers. I think you all clear with this, and we can see more videos in mathematics in the upcoming videos. Thank you for watching this video. Thank you, friends.